From the backyard of our own solar system to the distant shores of the cosmic ocean, the universe is full of mysteries. Despite all we've learned about the universe, including what it looks like and where it exists, there remain many cosmic unknowns. How do supermassive black holes form and grow early on? What were the very first stars like? What's in the atmospheres of super-Earth planets? We don't yet know the answers to these questions and many more, but when James Webb succeeds as an observatory, it should teach us the answer to all of these questions, and more. From exoplanets to supermassive black holes to the first stars and galaxies, the James Webb Space Telescope is showing us the universe as we've never seen it before. The advanced tools of this space observatory lets us see further into space than ever before, unlocking new insights into how the universe really works. The images can be so in-depth that the results have been described as a new age of astronomy. And in a world-shattering revelation, the Webb telescope has made a groundbreaking discovery by lifting the veil on the most distant star known in the universe. Join us today as we dig deep into James Webb's new shocking discovery that stuns scientists. In the vast cosmic tapestry, where stars and galaxies shine brightly, a hidden era known as the cosmic dawn once shrouded the universe. It was a time when a veil of hydrogen atoms concealed the light from nascent stars and galaxies, veiling the universe in obscurity. Contrary to today's transparent expanse, the universe's infancy was a time of foggy obscurity. It was the fierce ultraviolet radiation of the earliest stars and galaxies that, over eons, managed to pierce through this hydrogen fog, heralding the transformation into the luminous universe we witness now. In the quest to fathom these primordial realms, astronomers have long yearned for tools that could decipher the universe's enigmatic beginnings. And the James Webb Space Telescope, the JWST, a marvel of modern technology, has become a key instrument in this quest. This cutting-edge telescope's advanced capabilities have enabled astronomers to scrutinize the very stars and galaxies that took shape in the aftermath of the monumental Big Bang. That's why the scientific community and space lovers expect to explore the universe's farthest reaches through a synergy of terrestrial and space-based telescopes. Leveraging the Webb's telescope's remarkable observations and the intriguing phenomenon of gravitational lensing, scientists have recently lifted the veil on the most distant star known in the universe, Earendel. Earendel is a glimpse into the universe's past and allows us to observe it as it was a mere 900 million years after its inception, a meager 7% of its current age. Delving into the history of the universe, the initial billion years bore witness to a pivotal transformation. In the instant aftermath of the Big Bang, matter and light fused into a seething melee of fundamental particles. But in a fraction of an eye blink, cosmic expansion unfolded at a breakneck pace, ultimately cooling the universe enough for light and matter to disentangle. Roughly 380,000 years later, hydrogen atoms emerged from this cosmic mist, enveloping the universe in an intergalactic haze that blotted out starlight, plunging the cosmos into the cosmic dark ages. It was only with the advent of the first generation of stars and galaxies, hundreds of millions of years post-Big Bang, that the universe was bathed in searing ultraviolet radiation. This radiant energy ionized the hydrogen fog, gifting us the resplendent and intricate universe we behold today. Dubbed the Epoch of Reionization, this phase marks the universe's first billion years, when the very fabric of space underwent a profound metamorphosis. Our pursuit to comprehend this epoch involves unraveling the genesis of the earliest stars and galaxies, probing their characteristics, their luminescence, and their ability to shepherd the ionization process by emitting UV radiation. Unveiling the universe's faint galactic denizens necessitates a journey through time and space. Light's finite speed dictates that our telescopes can perceive objects as they existed in the past. For instance, light from our own Milky Way takes 27,000 years to reach us, affording us a view of its state 27,000 years prior. To glimpse the universe's primordial instance, an era spanning 13.8 billion years, we must scrutinize objects at astronomical distances. However, the galaxies from this epoch are so remote that they appear as faint pinpricks of light, their brilliance predominantly in the infrared spectrum. Enter the James Webb Space Telescope, the sentinel that can discern these feeble glimmers. Unlike its predecessors, it spotlights the dimmer, smaller galaxies that are statistically more representative and likely pivotal to the Epoch of Reionization. These unassuming galaxies are the subjects of our intense scrutiny, akin to understanding human evolution by studying diverse populations rather than focusing solely on outliers. Webb's advent has inaugurated a novel vista into the universe's dawn, enabling astronomers to unlock the secrets held by faint galaxies. Among these enigmatic entities stands Earendel, the most distant star known in the universe, which was discovered last year by the Hubble Space Telescope. It has taken 12.9 billion years for Earendel's light to reach Earth, meaning the star was shining less than a billion years after the Big Bang spurred our universe into existence. However, Earendel doesn't lie a mere 12.9 billion light-years away from us, because the universe has been expanding at an accelerating rate since the Big Bang. Now, the star lives a whopping 28 billion light-years from Earth. The Hubble Space Telescope was able to spot Earendel thanks to a phenomenon known as gravitational lensing, in which the gravity of a massive foreground object sort of acts like a lens as it warps the very fabric of space and time, bending and brightening light from a more distant body as that light passes by. The JWS team employed the same strategy by harnessing the space warping power of a gravity cluster called WHL0137-08 that just so happens to line up with Earendel. The $10 billion scope, the JWST, which views the universe in infrared light, got a glimpse of Earendel last summer, just after beginning its science operations. But that glimpse has now become something more, as researchers now have enough information to begin characterizing the record-breaking star. For example, JWST's NIRCam, or near-infrared camera, reveals the star to be a massive B-type star more than twice as hot as our Sun and about 1 million times more luminous, NASA officials wrote today, August the 9th, 2023, in a statement announcing the new Earendel observations. Our Sun, in case you're wondering, is a G-type star with a surface temperature around 10,000 degrees Fahrenheit or 5,500 degrees Celsius. Earendel, which was named after a character in J.R.R. Tolkien's The Silmarillion, a prequel to The Hobbit and the Lord of the Rings trilogy, may not be alone in its distant quarter of deep space. Based on the star's colors, astronomers think they see hints of a cooler, redder companion star, NASA officials wrote. This light has been stretched by the expansion of the universe to wavelengths longer than Hubble's instruments can detect, and so was only detectable by the JWST. The existence of a companion would not be a surprise. Most big stars like Earendel are part of binary systems, NASA officials noted. The JWST's observations are also shedding new light on the Sunrise Arc, the galaxy that Earendel calls home. For example, the scope has identified a star-forming region in the galaxy that's thought to be less than 5 million years old from our perspective. Its imagery also revealed a more established star cluster near Earendel that appears to be gravitationally stable and has perhaps even persisted into the present day, if its stars are still alive, that is. And more insights are bound to emerge as JWST continues to study Earendel and other ancient stars. NASA officials wrote, "The discoveries have opened a new realm of the universe to stellar physics, and new subject matter to scientists studying the early universe, where once galaxies were the smallest detectable cosmic objects." The research team, NASA officials say, has cautious hope that this could be a step towards the eventual detection of one of the very first generation of stars, composed only of the raw ingredients of the universe created in the Big Bang, hydrogen and helium. Put Earendel aside. Thanks to the Webb telescope's remarkable observation and gravitational lensing, astronomers also authenticated the existence of a faint yet pivotal galaxy named JD1. The galaxy offers a glimpse into the cosmos's past. It existed only 480 million years after its inception, which is only 4% of its current age. Its discovery in 2014 by the Hubble Space Telescope offered only an educated estimate of its distance due to technological limitations of the telescope. Since distant galaxies often masquerade as proximate ones, confirmation is essential before attributing properties to them. The James Webb Space Telescope's capabilities rectify this problem, bestowing the power to authenticate these enigmatic candidates. JD1, the fruition of a collaborative effort among global astronomers, is one of Webb's inaugural triumphs in corroborating a distant galaxy's existence, a validation that grants it the honor of being the universe's faintest galaxy discovered thus far. The technology, however, only paints part of the picture. Nature herself lends a hand through gravitational lensing. JD1, concealed behind the gravitational embrace of the Abell 2744 galaxy cluster, benefits from the warping of space-time that magnifies and intensifies its light by 13-fold. This phenomenon, akin to a cosmic magnifying glass, renders visible what would otherwise be an imperceptible gleam. JD1's enhancement visibility, combined with the James Webb Space Telescope's prowess, empowers astronomers to discern intricate details of the galaxy's structure and resolution. This capability ushers in the era of studying early galaxies at an unprecedented level, revealing whether they were solitary beacons or enmeshed in cosmic dances with neighboring galaxies. Through the lens of these distant and delicate entities, we not only decipher the cosmos's elemental building blocks, but also trace our cosmic origins, unraveling the epic narrative that birthed our cosmic home. But, noting that while the James Webb Space Telescope continues to provide answers about the earliest days of the universe, it's also discovering more questions. Question marks, to be precise. The James Webb Space Telescope at the European Space Agency, or ESA, released a stunning image, offering the most detailed look yet at two actively forming young stars, located 1,470 light-years from Earth, in the Vela constellation. In the image, the stars, named Herbig-Haro 4647, are surrounded by a disk of material that feeds the stars as they grow for millions of years. But just below those stars, in the background of the stunning deep space image, is an object resembling a giant cosmic question mark. Is the universe asking us something? It's unclear exactly what the question mark-shaped object might be, but its color and shape give us some idea. It's probably a distant galaxy or potentially interacting galaxies. Their interactions may have caused the distorted question mark shape. Representatives of the Space Telescope Science Institute in Baltimore, which manages JWST's science operations, told Space.com. According to STSI, the object's red color in the JWST image tells scientists that the object, whatever it may be, is quite distant. Even more exciting, this may be the first time we've seen this particular object, STSI added. Additional follow-up would be required to figure out what it is with any certainty. Webb is showing us many new, distant galaxies, so there's a lot of new science to be done. Matt Kaplan, an assistant professor of physics at Illinois State University, told Space.com that the object might be two galaxies merging. The two distinct features could easily be merging galaxies in the background, with an upper part of the question mark being part of a larger galaxy getting tidally disrupted, Kaplan said. Given the color of some of the other background galaxies, this doesn't seem like the worst explanation. Despite how chaotic mergers are, double-lobed objects with curvy tails extending away from them are very typical. Kaplan added that there are plenty of other possibilities as well, but he rules out a star due to the lack of the 8-pronged refraction spikes that appear to emanate outward from stars in JWST's images as a result of its mirrors. More stunning, discoveries such as this cosmic question mark are sure to come thanks to JWST's high-resolution near-infrared imaging capabilities, which allow it to peer into the far reaches of the universe, spotting galaxies as distant as 13.4 million light-years away that existed just 420 million years after the Big Bang. Over 750 pieces of peer-reviewed scientific literature using data produced by the James Webb Space Telescope have been published in its first year of operations, according to SCSI. In another groundbreaking observation, the Webb Space Telescope has detected the earliest known carbon dust in a galaxy ever. Using the powerful space telescope, a team of astronomers spotted signs of the element that forms the backbone of all life in 10 different galaxies that existed as early as 1 billion years after the Big Bang. The detection of carbon dust so soon after the Big Bang could shake up theories surrounding the chemical evolution of the universe. This is because the processes that create and disperse heavier elements like this should take longer to build up in galaxies than the age of these young galaxies at the time the James Webb Space Telescope sees them. The surprising finding here is that we can directly see and learn about the properties of these dust grains at such an early time, and we can tell they're carbon-based, research lead author and University of Cambridge scientist Joris Wittstock told Space.com. That's quite surprising in the context of what we've previously expected, he said. The team spotted this carbon dust in this sample of 10 galaxies by examining the light spectrum from them as part of the JWST Advanced Deep Extragalactic Survey, or JADES. Detections like this are possible because elements absorb and emit light at characteristic wavelengths, meaning that they leave their fingerprints in light from sources such as galaxies and stars. The aromatic hydrocarbon dust was given away by a bump in the absorption of specific ultraviolet frequencies of light. The question is, how did these young galaxies get enriched with carbon so quickly? A cosmic get-rich-quick scheme. The early universe was made up of mostly hydrogen and helium with tiny traces of some heavier elements, meaning the first stars and galaxies should have the same composition of just these light elements. Conventional models of the universe's chemical evolution suggest that heavy elements, like carbon and oxygen, are forged in the nuclear furnaces at the heart of stars. When the first stars ran out of fuel for nuclear fusion and reached the end of their lives, they exploded in supernovas, dispersing the material they had forged through the cosmos. This stellar matter is integrated into interstellar dust. When dense patches of this dust collapse, this material becomes the building blocks of the next generation of stars, which are thus richer in heavy elements and sit in similarly enriched galaxies. The wavelengths of light emitted by early galaxies are stretched by the universe's expansion as it travels across billions of light years, thus taking billions of years to reach us. This results in ultraviolet light from galaxies being shifted down the electromagnetic spectrum, a process called redshift. The more distant, and thus earlier, the galaxy, the more extreme the redshift is, meaning light from the very first galaxies is stretched out to infrared wavelengths. Light from these galaxies has been crossing the cosmos for as long as 12.8 billion years and is now infrared light. The JWST is the most sensitive infrared space telescope ever placed into space, and the only one capable of resolving features like these carbon fingerprints in the light from such distant galaxies. Regarding the future of this research, Wittstock explained that there are two possible avenues to explore. First of all, on the observational side, the JWST is collecting more data, so we can look at larger samples of galaxies and see if we can learn anything linking this carbon fingerprint with specific properties of the galaxies, he said. On the theoretical side, Wittstock said scientists may now start to think about what astrophysical objects and events could produce PAH carbon grains on a short time scale. Quote, "There is still a lot of work to be done," he concluded. The team's research was published on July the 19th in the journal Nature. However, what's most important to remember is that this is only the tip of the cosmic iceberg that JWST is revealing to us. In the great quest to understand the universe, the first science results from JWST have truly given us a giant leap forward, with much more to come. Well, that's all the information we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit that bell so you never miss out on future episodes. And be sure to tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content like this and to always improve. As always, thanks for watching, and we'll see you next time.